Okay, so if we go back to grade 9, we know that straight lines have like an mx plus c formula, and we know this is the gradient, this is the y-intercept. So there's two methods of drawing this. You could even draw it different ways, but if we just do the table method, we can just choose values for x, substitute those x's into our formula, and then get 2 times -1 is -2 plus 1 gives me 1. 0 plus 1 gives me, wait, so that is -2, it's -1. -1, this gives me 1. And then 1 times this gives me 3. So if I go to -1, -1, I can make a dot there, and then say at 0 and 1 I can make a dot, at 1 and 2, 3 I can make a dot, and connect those dots, and I can form my line. The alternate method is just looking at the different intercepts. So I can already see that my y-intercept I can read off here is going to be 1, so 0 and 1. To calculate the x-intercept, I just put y to be 0, and I can solve this by saying then 2x is -1, x is -1/2. So if I go and say this is 1, -1/2, so -1 is there, -1/2, I only need 2 lines, and you can see 2 dots to make a line, 2 points on there. I can draw the same graph. Okay, so this is grade 9 skills. You should be able to do this. In our absolute value graphs, we're going to get one line with a positive slope like this, and one line with a negative slope. Okay, so the only real difference is where grade 10 work comes in is we're applying a restriction. So we're going to draw it with a restriction. So if I said I want to draw the same graph, so we know how it looks already, but now I want a restriction so that it's only when 2x plus 1 is greater than 0. I can solve this by solving this. I can say only when x is greater than -1/2. So it basically means only where my graph is positive. My graph is positive above the x-axis. So if y is equal to this, y is positive is above the x-axis. So only where it's above the x-axis, so that makes sense. If this is -1/2, it would be above the x-axis. But I don't even have to stress about what it means. All I know is that I can go to -1 and say -1/2. Over here I can place a circle because it's not included, and I know I'm only going to draw greater than, so to the right of this point. My next points are, I can find points on the line by either doing this with the table method or doing this and say, oh, the line would go through there and through -1, so it would go like this. But I'm not going to draw in the entire line. I can indicate where it would go, but then the only places the line actually exists is to the right of -1/2. So -1/2 to the right of there, there's my line. So if I had a different restriction, I would just go and calculate where is my x values allowed and draw that. But for us, it will always be to the right of some point x. It could either be on the x-axis or a bit above. We'll see an example now. Okay, so as a different example, if I have a line y is equal to 2x plus 3, that line is easy to draw. That's grade 9 work. Now, if I apply a restriction to it where 2x is smaller than 0, I can go and solve that restriction and just say that's also where x is smaller or equal to 0. So now I can already say, okay, it's only to the left of the point 0 here. So I'm only going to draw it to the left of that point. Okay, now I can go and look at this line. I can either draw a table, or I can solve for it and say, okay, my y-intercept is 1, 2, 3. So I have 1 point. Solve for my x-intercept, 2x plus 3. So x would be -3/2. So I can go to let's say this is then 1, 2, 3 again. Negative 3 over 2 is going to be in between negative 1 and negative 2. So over here is my x-intercept. And I can draw in a line. Let's just do a dotted line first again. This would be if I didn't have a restriction. My line would be here. Now I go and look at my restriction. This is the domain. Where am I allowed to draw this function? It says to the left of 0. So in this case, to the left of 0 would be like this. If I had a restriction that said, let's do the same line, so this line, but let's say where 2x, let's say plus 2 is larger than 0. Okay, and I can put a solid line over here since it was included. I can solve for my restriction, 2x larger than negative 2, so it means x larger than negative 1. So I can solve for that. I can draw the same graph, so I know it would go through 3 and negative 1.5. So I can know my 2 points are on there. If I draw a dotted line, it'll look the same again. But now I go and look, it's supposed to be drawn for x greater than negative 1. So negative 1 is here. There is my line on negative 1. I can do actually a supposed to be an open circle because it's not included. Okay, there is my point, and it's only to the right of this. So I can draw into the right of this. So whatever value this is, I can just go and find where it is. Where does my graph intersect with negative 1, or if it was draw it for x greater than 3, I would go up to here and draw it from there to the right if it's greater than, to the left if it's smaller than. Okay, so as long as we can do that, we should be fine. Then what we have is, if you look at the other video, it's on absolute values, and it just says, okay, it's always the positive value, so the distance from the origin to whatever points I have. So for positive x's, if x is positive, then it will just be x. If x is negative, then it would be minus x. So applying this to examples like this, I would have negative 7. So then I go and look which condition does it satisfy. Negative 7 is smaller than 0, so it's this. So it should be negative x. In our case, x is negative 7. Negative 7 gives me positive 7, so it spits out a positive value. If it was a positive value like 7, x equal to 7, then 7 is greater than 0, so I'm using the top one, so it would just be equal to x, which is 7. Now, this same thing can be applied to a complete unknown value, a variable, like x, for instance. So x minus 3 or x itself. If I apply this definition, whenever, so if x minus 3 is greater or equal to 0, so this thing inside is greater or equal to 0, then my answer is just whatever's inside, because it's already positive. If what is inside x minus 3 is negative, then my answer is going to be negative of what's inside. This would be how I apply the definition. So we would also have to go and look at this and solve our inequality further. I won't for the top one, let's do it for the bottom one instead, and say, okay, x minus 5. So firstly, if x minus 5 is greater or equal to 0, then my answer is just x minus 5. If x minus 5 is smaller, it would be negative x minus 5 if this value is smaller than 0. So if I go and solve this properly, it would be x minus 5 if x is greater or equal to 5, and negative x plus 5 if I go and distribute in my minus if x is smaller than 5. So you'll see it's around the same point. Our absolute value graphs will meet at some point. So it will always be the same number, larger than or smaller than the same number, and then just have two different graphs. So if we just look at this, if this problem was instead not to draw this entire crazy y is equal to this entire function, instead drawing just the top part, like x minus 5. So y is equal to, I'm just going to say is equal to y, or drawing y is equal to negative x plus 5. This we can do with the grade 9 techniques that we discussed. So that's easy. Either draw a table or go and look at your intercepts. This one would obviously have an intercept at positive 5. This one would have an intercept at negative 5. And then we can solve by setting y to 0. X would be an intercept at 5. So this graph would look something like this, at 5 over there. This graph, if I set y to 0, x would be equal to 5 as well. So 5, and it would look something like this. Okay, the reason I drew it in as dotted lines is we're not just graphing this as a graph and this as a graph. We're looking at this with the restriction x greater than 5. So I'm only drawing it where x is greater than 5. So let's look at this function. This only where x is greater than 5. So where x is to the right of 5. So this would be the graph. If I look at this one, x negative x plus 5, whenever x is smaller than 5, to the left of 5. So I only draw it to the left of 5. Let me just press a bit harder to actually show my line. Ignore the ugly line there. So I'm not drawing it to the right. And then this one is not included, so I can put a circle there. This one is in fact included, so I can put a solid dot there. So if I draw it as two different functions, just with restrictions, we should be able to do it. If I just want to draw the entire thing, it's just saying, draw these two things, both of which are true for this, so draw them on the same axis. If I want to do that, I know they both intersect at 5. Okay, this one is a solid dot, that one an empty dot. If we put these two over each other, the solid dot is going to win out because it is included at least one of them. And then to the right, it looks like that. Okay, to the left, it goes through 5 over here, and it looks like, so it should go exactly through 5 though, and it looks like that. So that V shape is going to be my absolute value graph. So it's just graphing this and graphing this on the same set of axes, or same axis, same coordinate, Cartesian plane. So that is essentially all that graphing an absolute value is going to be. It's always going to be like a V shape like this. The V shape would just maybe move to the right, to the left. If I added something to this like a plus k, if I add k to my y, it's just going to move it up. If I minus k, it's going to go down. So I can just shift this up or down, but it's going to stay a V shape that can just move to the right or left or up or down. How it would move, I can quickly show you. Okay, so if it's just the absolute value graph, it's going to be a V like this. If it's a negative of an absolute value graph, it's going to be what happens if I put my y value negative. Y is equal to this, so it's negative of what it was. It's a reflection over the x-axis. So it's going to be upside down. So upright, and this one upside down. If I plus 2, it's just going to shift 2 up. If, just like a graph mx plus c, if I change the 2, it's just going to change where my y-intercept is. If it was inside the absolute value plus or minus k, then it doesn't move up or down, it moves to the left or right. If I plus, it's to the left. If I minus, it's to the right. I'm going to upload a video that shows how these functions actually change with plus or minus inside here or over there, so you can see how it moves the shape around. But the important thing to note is all that drawing a graph like this would amount to is drawing one function if x is greater or equal to 2, and a second function negative x plus 2, so I just put negative of this entire thing if this entire thing is negative, so if x is smaller than 2. It's going to meet at the same point. To the left, it's going to look like this. So this graph that you should be able to draw using grade 9 maths. To the right, it's going to look like that one, which you should be able to draw with grade 9 maths. This one has a negative slope, so it's going to go down. This one has a positive slope, so it's going to go up. And we can see it's a positive in front of here, so it is the V shape. The negative 2 is just going to mean it's going to move 2 to the right. So it's actually going to be over, whoops, that looks ugly, over there at 2. Try and draw this one and see it will intersect at 2 there, included because of that inclusion, and then get exactly the slope. It's where it crosses the y-axis can be asked, so try and figure that out. Where's its y-intercept? Good luck.